All right, guys, let's run through our 4 problems on the 7.2 homework. We're talking about similar polygons in this section. And the important thing to understand about polygons, if they are similar, was 2 important ideas. Number 1, all of their corresponding angles are congruent. And number 2, all of their corresponding sides are proportional. So we're supposed to determine if these 2 polygons are similar or are not similar. So the first thing we would want to think about is, are the angles congruent? Well, it looks like in this case here, we're dealing with 2 rectangles. All of the angles in the first figure are right angles. And sure enough, all of the angles in the second figure are right angles as well. So yes, all of our corresponding angles are congruent. The second thing we would need to check, and this is the harder one, is, are your corresponding sides proportional? So to do that, you usually can't tell just by looking at the figure. You've got to set up a proportion, a fraction or a ratio equal to another ratio, and find out if they're actually the same or not. So let's pick a side in the first rectangle. I'm going to start with the longer side in the first rectangle, which is 12. The 12 corresponds to the longer side in the second rectangle, which is 18. So I've got a ratio of 12 on the top to 18 in the lower rectangle. Equals, now we're going to go to the shorter sides. The shorter side in the first rectangle is an 8, and the shorter side in the second rectangle is a 15. So we've got 2 ratios of corresponding sides, and it's time to figure out if those 2 ratios are the same or not. So the way we would test this is by cross-multiplying the 12 by the 15 and the 18 by the 8. So let's see what happens here, everybody. 12 times 15 is going to give us 180 for that first product. In fact, you know what? That one might not be obvious, so let me go ahead and write that down, what we did. We did 12 times 15, and we wanted to know if that was equal to 18 times 8. So the 12 times 15 gave us 180, and 18 times 8, if I'm not mistaken, is 144. Those 2 numbers right there pretty obviously are not equal to each other, which means this is not a proportional relationship. And because those corresponding sides are not proportional, we would say that our 2 figures here are not similar. Now, if we ended up with something, and you will on some other problems, where these 2 numbers ended up being the same, say it was 162 is equal to 162, then we would say yes, the figures were similar. So that's how we're going to do that first problem. Let's move on to number 5. Now the directions are important right here. They tell you, everybody, that the polygons in each pair are similar to each other. Okay, so we can put our little tilde right here showing that these 2 figures are similar, meaning that their corresponding angles are congruent and their corresponding sides are proportional. So our directions now are to find the scale factor of the smaller figure to the larger figure. As we talked about in our notes, the order here is important. We're going from smaller to larger, so that's important. And we define scale factor simply as being the ratio of 2 corresponding sides. So for our scale factor, all we need to do is pick one side in the first figure, and let's just pick the first one we see here, which is 16, and make that in a ratio compared to the corresponding side in the larger figure, which is 24. And what we always need to do, you guys, is simplify our ratios. 16 and 24 have a greatest common factor of 8. So we'll divide that out. 16 divided by 8 is 2. 24 divided by 8 is 3. And 2 to 3 is your scale factor. Now you'll notice here, guys, I expressed the answer as a fraction. They've given you the answer right here with a colon. Both of those are acceptable ways to do your scale factor. Now, just to notice, I chose to use the 16 and the 24, but because these figures are similar, you could have done this 2 other ways. You could have done the ratio of 10 to 15. In this case, your greatest common factor was 5. 10 divided by 5 is 2. 15 divided by 5 is 3. There's the same answer a second way. Or you could have used these bottom sides. The ratio of 12 to 18, those 2 numbers have a greatest common factor of 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So no matter which pair of corresponding sides you use, we ended up with the same scale factor of 2 to 3. So as they say, there's more than one way to skin a cat. They do say that, but don't Google it. It's gross. Anyway, let's move on to number 9. Now again, the directions tell us here that the polygons in each pair are similar. We're now supposed to find a missing side length. Now I absolutely hate the way that these CUDA worksheets do problems like this. We haven't used question marks really since we were in about 3rd or 4th grade. We generally want to put a variable there in the place of that question mark, and everybody likes to use x. So we're going to call that side x and now try to solve for it. So because these polygons are similar, we know that their corresponding sides have to be proportional. So I like to set up a blank proportion. A fraction equals another fraction. And there are actually, we've checked this out before, 4 times 2. I think there's 8 different ways that you could actually do one of these proportions. They're all going to get you the same answer if you do them correctly, but we'll try to do this in an orderly fashion. Let's start with the 15, which is the top of the smaller figure, and ask yourself, what side in the larger figure on the right does the 15 correspond to? Well, if I look at the two side lengths of 15 and 24, obviously 15 is the shorter side. So we want to use the shorter side over here, which certainly appears to be 20. So our first ratio of corresponding sides is 15 to 20. That equals, now we're going to go to the longer side of the smaller figure, which is 24, and the 24 corresponds to this x over here on the right-hand side. And x is what we're looking for in order to find the missing side length. So, since we're using in the old days, before calculators, I would have told you to simplify this ratio here by dividing out the greatest common factor, but since we're using calculators, I don't think it's going to be too bad for us. The 15 is going to get multiplied by x, and the 20 is going to get multiplied by 24. You could do this in either order, but I always like to do the variable first. 15 times x is going to get us a product of 15x, and 20 times 24 is going to get us 480. From there, just to get x by itself, we simply need to divide both sides by 15. 15's cancel there, and we're going to end up with x is equal to, and I believe that's going to get us 32 for our answer there if we type that into our calculator. And sure enough, that is the answer that we were looking for. X is equal to 32. So there's our missing side length in number 9. 10, 11, and 12 should work the same way. And really, number 13 through 16 are going to work similarly. Now, the one thing that was interesting, I thought, about these last 4 problems, they are telling us now, I should have said this first, that the polygons in each pair are similar. Okay, they should have said that initially. But what I want you to notice here is that the orientation of these two figures is different. In every problem that we've done so far, number 1, they were rectangles that were kind of facing the same direction. They were wider than they are tall. In number 2, you've got 2 quadrilaterals, both pointing or facing in the same direction. Number 9, 2 parallelograms, it looks like, both facing the same direction. But in number 4, you've got these 2 figures which kind of appear to be trapezoids. The top one kind of has this pointy acute angle in the top left corner. The one on the bottom has this pointy acute angle in the top right corner. Not sure if that's going to end up being relevant or not, but let's see what we've got. Now, the only 2 side lengths we know in the smaller figure are 20, which is the shorter of the 2 parallel sides, and 28, which is the longer of the 2 parallel sides. That means that as we go and look at the top figure, we are interested in the parallel sides, this one and this one, and this 30 and this 31.5 aren't going to figure into this at all. The 30 would correspond to this side length right here, but we weren't given that. And the 31.5 would match up with this side length here on the right, but we weren't given that either. So let's see what we do know. In the top figure, the top side, the longer parallel side, has a length of 3x minus 1. That would correspond to the longer parallel side in the second figure, which is 28. That ratio is going to have to equal, and now here we go, back to the top figure, we now want the shorter parallel side, which is 25, and that corresponds to the shorter parallel side in the smaller figure, which is 20. All right, so 3x minus 1 over 28 is equal to 25 over 20. And we're going to do some cross multiplying here. Two things make this complicated. Number one, we have a binomial right here multiplied by a monomial. And then the second thing is we've got some pretty big numbers here to deal with. So let's go slow with this one. We're going to take 20, which is our monomial, and multiply that by our binomial, 3x minus 1. But anytime you're multiplying a monomial by a polynomial, we need to have parentheses right there. Equals, and the other cross product is going to be 28 times 25. Okay, so I would imagine that everybody, actually I would do this a little bit differently, but nobody in the world agrees with me. Everybody's going to want to distribute that 20 in there, so we'll go with that. 20 times 3x is going to get us a 60x minus 20 times 1 is 20, and that equals a 28 multiplied by 25, which is going to be 700 on the nose. All right, we're going to add a 20 to both sides here. And that's going to get us a 60x, those 20s cancel, equals 720. And last thing we're going to do now is divide both sides of this equation by 60. 60s cancel out, and that's going to leave us with x is equal to, and sure enough, 720 divided by 60 is going to tell us that x is equal to 12, which, yep, was the answer that we were looking for. All right, so give 14, 15, 16 a try, and those should work the same as 13. Good luck, guys, and if you have any questions, please post them in comments, and I can work out a few more problems.